things going together with a different color no longer fits the same, because a different color can change how the material shrinks and behaves. A different material obviously changes how everything shrinks and behaves. A different resolution changes it, a different infill changes it, a different machine changes it, a different nozzle size changes it. And it is almost impossible to rely on printer settings to make sure that the same files printed on different machines in different situations all behave exactly the same, unless you very, very intentionally design the parts appropriately so that they do. So let's go ahead and run through all the variations of how to design both the base and the lid so that you get them to fit exactly how you intended every single time, regardless of what material, color, or machine anyone is using. Let's go ahead and start with the baseline, very simple kind of CAD model where you just have a square base and a square lid and they fit together here. This is really poor design. This is kind of entry-level design. What you want to do is you want to actually optimize for the process that you're working with. The very first thing you want to do is go ahead and round all the edges. This ensures that you're able to get rid of any potential warp around these individual corners, and you also eliminate kind of contact stress areas at these sharp corners, because as the nozzle is going around, it can bounce or there can be flow delay, those kind of things that will cause these corners to suddenly become dimensionally inaccurate. If you round it off, you no longer have that bang bang location, which is what it's called, where you have a sharp corner and you have to change direction. You have this rounded out direction to where it can fit very snugly inside of there, and it's just these side faces that are far truer than individual sharp corners can be. In addition to that, on the bottom, you always add a chamfer to the bottom of any given part, and that ensures that you don't have to worry about elephant footing or anything on top, but that's more cosmetic than anything else. Right here, you can see the other little trick that we did on this one, which is one of the easiest and simplest to implement, which is this small chamfer over on this side. You can see that this edge is slightly angled as compared to this one, which is perfectly vertical. The reason you want to do this is because now, instead of having one single dimension that everything has to fit to, you can actually have multiple dimensions so that you know that will at least start, and then it can be pressed in the rest of the way. And then you can adjust this and play around with it different ways in order to get more tightness. Since I just basically applied this chamfer right here, it fits a little bit loosely on there. But if I was to expand these dimensions just a hair, you would start to have this slide to where it comes in on the top and then it can slide in and interlock. And this is a really good way for making kind of one directional lids that just press together and then never come apart. But you know that it will always fit, and you know you will get that wonderful press fit without having to worry about it not being able to go together, like in this case, to where they can't even get started. You will allow this wedge to wedge into the cavity. Now there are ways of evolving this. Obviously you have the top right here with the chamfer on the side, so this acts a little bit like a wedge. But you can also just evolve it a bit to where you're using a fillet on the top so that you have this starter edge, and then you can still have this large horizontal surface so that you get better interface with the outer edges like that. This creates a tighter kind of a fit, but still allows you to start on it, but also creates that robust dimensioning while maintaining all the rounding out the edges that you need. But the problem with this one is that when you have the solid inner base, you have a potential shrinkage in there. Depending on how the infill direction is going or what type of infill is being used, the shrink on this can be different so that these side walls are a little bit different. In order to adjust for that, you can basically go to a thin wall. Just cut out the inner cavity, and now you not only get a little bit more flexibility on these if you make them really thin, but you also reduce the opportunity for infill to affect the dimensionality of your part, because this is basically just the walls, so you know they will always be solid. And in this case, you have a much more reliable set of dimensionality, because instead of having shrink pull this in to where it enters more easily, this part is much truer to true dimension and is therefore a little bit harder to get in there, because these two have the exact same dimensions, but for some reason this one goes in a little bit easier because it has a little bit more shrink than this one, which has a little bit less shrink. But you can take this idea of the thin walls a little bit further in order to get more flexibility in how you design this stuff. You can take those walls, make them very thin, and start to change their pattern. Right here, this is designed to literally just have contact with the outer corners. So with this, these four corners are now the only contact areas. It can slide in a little bit more easily, and since it's thinner walled than the original, these can actually flex a little bit. So if for some reason the dimensions are a little bit off, you know somebody can press it in and probably still pry it out, and know that they're not just grinding on the part and forcing it in there, because this is effectively a compliant mechanism. And you can lead into that even further. This is a truly compliant mechanism. What is the difference here? The difference is this one has the star fully embedded into that base plate to where it is a solid wall, whereas this one has had cuts taken out underneath the bottom here to where these individual walls are able to flex themselves, which again gives it more compliance so that it's able to insert in there even more easily than the original was able to, because it just has a little bit more space. But the danger with those kind of compliant features is that you want to give a gap underneath here of about 0.3. This ensures that at any resolution, the part can still be printed and that gap will still be present. But 0.3 is so small that sometimes slicers and 3D model systems will attempt to adjust it or consider it a defect. So right here, you can kind of see how there's this cross patterning right here. This is because there was that cut into the part in order to create the slot underneath here, but it's so subtle that the STL itself was kind of modified in order to create these artifacts that kind of close up those holes. So you can make it a hair bigger, you can go as large as 0.5, but at that point you can start to get deformation in your features. So you want to keep it as close as you can, minimum of 0.3, and then you can go bigger based on what you need to do. But now you're starting to get into the weirdness of slicer settings. 0.3. Point 0.3 is generally the best. Make sure your STL is clean and good. One way of taking this compliance feature even further is with these types of shapes. Right here you can see a split version of this U shape that allows it to bend a lot because it's just two thumbs pressing up against the wall. And right here is a solid version that also has just a little bit less compliance because it's fully solid. But this allows you to have lots of flexibility. So if you want a part that's a little bit sloppy or just a really loose pull so that you know people can always get it out, but still have good contact, you can create these types of spring features in here. Again, gap between the layer, 0.3 high, and then you can just press it in there and it pops in there really well. And you can adjust the tightness of that by flattening out this U and that kind of stuff. And of course you can soften it up by splitting it so that it has less compression on the outer wall. And you can mess with these kind of compliant features in all kinds of different ways. I like this one because you have the square down at the bottom in order to position the lid appropriately in the base, but you still have plenty of room to mess around with the spring up here. And you can make it softer and harder by making these thicker, pushing it out a little bit so that it squashes more, all kinds of things you can do about that on the baseline of springs. But these are really good ways of designing the lid to fit into whatever base you have. But the lid is not the only component in this part. Sometimes you cannot redesign the lid. Sometimes you only get to work with this. And this original design right here is also terrible because again, sharp corners and bad design throughout. So first of all, let's go ahead and run through that design and make sure bottom is chamfered, make sure the inner corners are all rounded. Now you have a part that is well designed for 3D printing, at least as a baseline. But the corners create a lot of contact area to where if you have a standard type of lid, there's just so much surface area for it to interface with, maintaining a consistent fit and feel can be difficult. So what you can do is just reduce the amount of contact area. And a simple solution to that is doing things like this, where you basically cut out the corners so that they're no longer interfacing with the lid. And now you just have these nice flat outer sides that are very precise, very reliable, and very consistent. So you don't have the corners contacting anymore, you just have the outer walls. So now those two parts can press together really well, whereas the black and the purple do not fit together very reliably at all. And if they do, they're not coming apart. But with this design, it is still a solid part. It is going to hold its dimensions and it's not going to stretch or move at all. And having some level of compliance inside of your part can be a lot of help. So that's when these types of features can be handy. These little splits in the corners can allow the part to spread and bend so that when you have something big and rigid like that, the outer part can adjust and move so that it goes in really easily. Again, as compared to something like that. Now, these splits can be really dangerous because they are in the plane of the layer lines. So if you put a ton of these in there, they can help the parts split off. In this case, it's okay because they're 90 degrees from each other. So even if this one starts to split, it is still supported over here by the other side, but you can make them more and less subtle just to give you the little bit of an edge that you need. And just be aware of that potentiality. Don't try to make this an uber press-in part to where you're wanting these to splay out a 0.5 millimeter or something, because that that will cause splitting in the layer lines. But if you've tuned up all the tolerances for the most part as well as you can, and you just want a little bit of a safety factor there, that is where these can be really, really useful. But now let's go ahead and move into some really advanced stuff. And this is only for the pro modelers out there. These are great. These allow your part to bend and move a little bit in order to get it out. But you will still have variability in how the lid interfaces with it. Based on different lids and different colors and so on and so forth, all the things will fit just a little bit differently between these based on the pressing of it all. But if you want the exact same fit, the exact same force to press in and the exact same force to pull out, every single time, independent of anything about print settings, you need to really mechanize this thing, and you need to use something like grip fins. These are a large series of flexible fingers that not only decrease the contact with the part, but hold it at the exact same pressure all the time. These are an advanced engineering one, and the way of modeling these is that you literally just extrude them into the wall and then cut out underneath them so that they are free to flex. Now, plastics tend to creep, which means that over time they can kind of adjust their position and they just move to a new place if you keep on pushing on them. This is what grip fins can get to, but it depends on the plastic that you're using and how long you want them to be used for. This is a perfectly reasonable application because the pressures are distributed against a lot of grip fins, and in this case, they're deflecting so little that over time you're gonna lose almost none of the pressure that this lid is put under to hold it onto there. But this is stupidly reliable because each one of those is compliant, they look really cool, and they allow you to create a fit with the lid that will always work. This is easily the most reliable way of doing it. Compliant features within your systems are very easy to design. They do not have to be complex. But if you want them to be really good, you can go as complex as you want. And this allows you to make stuff that is really, really reliable, really, really robust, and can be made at any time, anywhere, all the time. And this is the reason we care about it, because inside of our print service teleport, we have people uploading whatever sort of part, and our machines aren't necessarily the same as your machines. So it's really important to design your parts to be reliable so that you can have them produced. And it's important to understand the engineering and the design to get that done. So if you are looking to create a product and you don't really want to run a print farm anymore, you might check out Teleport over at slantpod.com, that's slantpod.com, where you can just upload a model, connect it into your Etsy store, and then whenever you get an order, we will print it and ship it directly to your customer for you. So if you want to start up a 3D printing business, go ahead and check out our other videos to see other nifty design tips, and then go ahead and check out Teleport if you really want to scale up your 3D printing operations. Have a great day, everybody.
We have got to the point where literally anybody can build a fully working app without knowing how to code. This is base.
We about to watch these together, yo.
Review just in. Beautiful work, excellent service. Fell in love with the guy on the phone, 5 stars.
You know, sometimes you want multiple parts to stick together, but you want to do it in a way to make sure they stay together consistently, reliably, and continuously. So in this video, we're going to go through joining features, how a lot of people design them, and some better ways of actually getting them made to have your parts stick together really well. So the first and most common type of joining feature is really just a tongue and a slot. And this is a decent way of doing it because it's easy. You make a square on one side and a square on another side, and then you have them slide together or press together. And this isn't a bad deal, but it's kind of not very useful because they don't hold together very well. But if you are designing these, make sure that you chamfer the insert just a little bit. That way it's able to wedge into the main slot. And then the 3D printed layer lines can actually cause them to lock together pretty reliably. But again, you don't have any sort of pull or forcing to make sure that there's no gap in between the two pieces. Also, it's just kind of cumbersome because there's a lot of tolerance issues within it. So this isn't the greatest type of locking feature, though it's the one that a lot of people go to. But let's move into one that's a little bit more robust. Another option that a lot of people use are T-slots. And T-slots are actually pretty decent because they actually have some lateral support, so I can't pull these apart. And they're actually not too bad to design, and you can actually use the same kind of chamfering on the top of the tongue itself so that it angles up and locks into there. And this is fine, but the problem is that you now have several different tolerances to have to deal with. You also have a pretty complex first layer where this can warp and curl up when it's going down on the first layer if you're using a high warp material or want something that's robust in manufacturing. So even though it is functionally okay, it's not great. And again, you have the tolerance issues of having to keep that seam pulled together. And based on material shrinkage and other types of issues, this won't always work very well. So having something that is tight and flush, just like this, isn't always a very viable option. But there's an upgrade to the T-slot, and that is this. You can actually take the T-slot and curve it just a bit so that now you have taken the two outer flanges of the T-slot, and instead of them being straight to where they press into a hole with a friction fit, they are instead acting like springs. So that now you have a part that is able to go into the slot and lock in so that now there is no jiggle, no tolerance issues at all, and you're able to have kind of flexible tolerances that you can deal with material shrinkage and other types of issues. The other thing that we've done is, since we don't want this complex first layer on the part, we went ahead and angled the slot. And you can apply this to any of these, but by applying that angle, you now have a very simple square first layer that with some rounded filleted outer edges so that you have good corners. And then the rest of the complexity happens later in the print to where it's very easy to control and you don't have to worry about warpage on the bed or adhering to the bed. You just have it print. So you make sure that it's chamfered there, and then the two outer flanges are chamfered as well. And now you have something that can lock together super tightly, super reliably, has no jiggle, and has a very nice tight seam that will always be a very nice tight seam. The one downside of this is that you have basically this hole in the bottom of your part, which isn't always necessarily desirable, but you would also have the hole in your bottom of the part with any other types of slots, just have it outlined. So long as this is a non-customer facing feature, it can work pretty well. But there's some other types of slots that we can use. One of the more common ones is the I-slot, where you use a circular flange for the tongue. Now, the benefit of this is that it is easier to design than the T-slot because you're not doing all the XY tolerancing that is necessary. You just have one single circle that is dead centered dimensionally to the other circle. And then, of course, you chamfer this so that the two of them can lock together. And again, you get that advantage of 3D printed layer lines basically binding together so that it doesn't really want to come apart very easily if it's a really tight one. And you have a decent flushness, but again, the other problem with tongues in general is that you can have this spread at the top, this angling, to where the bottom slot is holding together, but the top of the part is not held together, so it kind of flexes like this. And that again is a problem with those kind of short, stumpy slots. You can of course make them deeper, but then you're dealing with a lot more friction in putting them together, because this can be a decent amount of effort to put together. But the I-slot is really useful because it's very easy to design, very easy to tolerance, and is generally a nice looking design. It is also technically a simpler first layer. So if you have a tongue that has to be printed face down to where this has to be against the bed and you can't do the angled thing that we showed on the spring T-slot, this is a way to get around that because these are nice smooth curves all the way around, so there's a low chance of warping or any sort of other issues on first layer that can come up. But you can also take the I tongue and slot and change them just a little bit. You can actually use grip fins. Now, grip fins are a flexible feature that you have to design pretty carefully. They cannot be connected to the roof of it, but they are these small tabs all the way around the hole. And these small tabs allow you to take a much larger eye tongue and shove it right in there to where it locks in, and you have the flexibility of these outer features holding it in place. Now you can have it be a rigid feature like the regular eye slot, to where you just have a very low tolerance hole right there, which can be useful in certain situations because it gives you some flexibility. But it's also useful to actually make flexible joints or semi-flexible joints, to where you can use those grip fins to hold on to the eye tongue so that you get just a little bit of give inside of there. And it also pushes back and forth, and you have flexibility throughout while still holding on to the part reliably and centering it. And you can change the stiffness of these fins by making them thicker, making them longer, so that they grip that eye tongue even harder than they normally would. But all of these assume that you have to use tongues where two separate parts insert into each other like this. And while this is fine, it's not very robust. And again, you have that first layer problem. None of these really pull it in except for the flexible T-slot. So what is a design that we could actually use where we take advantage of 3D printing really at a large scale? Because all of these parts can pretty much be made with any other process except for the grip fins, which are impossible. They use an impossible geometry. What if we could take all of these, put them together, and make something that can't really be made any other way? Well, if you were to do that, you would end up with something like this. Now, these are just locking tabs, and the reason these don't really exist generally is because they are impossible to manufacture. This internal hole right here has two recesses inside of it, which cannot actually be machined or manufactured or molded with anything other than 3D printing. So what we are able to do is create those two recesses and then create two locking bumps on either side of this part so that these two little tongues, these flanges, flex just a little bit. And now you're able to take them and press them into that slot and have it lock. You can change the tolerances so they pull tighter. You can also change these bumps so that they are actual lock-in. Right now we made them bi-directional, so you put it together and pull it back apart. So if you're making a building kit, this can be really useful. But you can make these so that they lock in there permanently and pull it in super tight so that there is no flexure at all. But it's very quick and easy to assemble, and you don't have to deal with all the other tolerance issues of the other pieces or the first layer issues. In addition to this, we also print these parts just like this. So this brick actually sits on the build plate like this, and these flanges do not need any sort of support at all because we angled them on the bottom. So this part can come off fully complete. This part can come off fully complete. They have very simple first layers where we don't have to be concerned about some complexity that would cause them to fail or warp. And they lock together very quickly and easily, and they give you an advantage that has never been possible before. So if given the option, I would recommend doing these because these use just a smidgen less material, they're more reliable, they're easier to assemble and work with, they're also fairly easy to tolerance. So if given the choice between all of these locking tabs, I would use these. But hopefully that gives you some insight as to how to design locking features or joining features so that multiple parts of either terrain or an architecture model or maybe just a building kit can be put together in a way that is reliable and very manufacturable without having to worry about high cost or high rejection rates because of complexity inside of the model itself. Let us know if there's other basic features out there in 3D printing that you guys want us to cover. We try to go through all of these basics to know how to design a really good mass production 3D printing part. So comment down below any ideas that you have. Have a great day, everybody.
Hinges are a fundamental part of all kinds of parts, but did you know you can actually make the hinge a part of a part? It's called a living hinge, and if you put a living hinge in any sort of part, you can make those parts actually have a party. So let's pick that apart. So there's a lot of different types of living hinges, but inside of 3D printing you have all kinds of different options because you have a lot more control of the pieces that you're making and the designs that they're able to make. The most traditional living hinge is literally just a thin flap of material, which is made very thin so that it can flex without actually fatiguing. These type of living hinges though do have an issue because they wear out. They're often used on something like old tackle boxes or small enclosures, and they're fine with traditional manufacturing, but they can't be used many times and they can't flex through very long distances, otherwise they break. like that. And while that's not an ideal situation you want to have in a lot of parts, you can do it inside of 3D printing with certain types of materials. So a typical living hinge can be done with like TPU or polypropylene or other types of materials, so it can be mass produced and create a good reliable piece. But you also have to consider the orientation of the part. It can only be printed on its side, which can limit it to some degree. There are some variations of that where you can still have a living hinge and have it be reliable, but it's a difficult type of geometry to kind of have to work with. And fundamentally, it's not very good engineering because it is a point of fatigue that'll eventually wear out. And there's so many other options when you have 3D printing. You can reduce the wear on a particular living hinge just by giving it more material to wear on. So like in the case of this circular hinge, all you are doing is giving that stress more places to go by giving it a much larger area to work on. Rather than a very small defined point, you have it on a very big broad point. It doesn't give you quite the same range of motion because you can flex stuff a lot more, but it puts an automatic spring into the hinge so that you now have a lid that automatically closes, and a lot more play and a lot more flexibility in narrow ranges than the typical type of living hinge would ever provide. But you can take that circular hinge a little bit further, and by reducing the amount of material even more and giving it kind of this toothed look, you can give it a lot more flexibility, a lot more longevity, and still have the spring return. But by changing the depth of those grooves and the number of those grooves, you can actually kind of change how that hinge behaves. So the circular hinges are another way of doing living hinges. But sometimes that circle will pop out too far into a particular geometry, so you might still want that flexibility with much less protrusion. A long time ago on a project that we did with robots, we actually created a gripper finger using this kind of spring hinge. And this sort of living hinge is very useful because again, you get a good amount of flexibility with very little wear because no single part of the hinge actually has to flex very far. This is a good way of creating like long articulated columns or multiple hinges inside the length of a long thin part so that you don't have to have a single plate of wear like a traditional living hinge, but you still have a good amount of flexibility. One of the more traditional hinges is actually the living hinge that you might have seen in like woodworking. And this is where you cut individual slats inside of a horizontal plate that is printed just like this. But those individual slats are able to twist and bend around each other. And by creating that twisting motion and freedom within it, you're able to create something really flexible. It's not just a perforated edge where again, the material is flexing directly. It's just twisting these individual areas just a little bit, kind of the way you twist a rope, just like this. So this is a copying pattern of basically having a piece of material connected right here and then two edges that bend just like this. So that gives you a lot of freedom. It can bend pretty darn well, but you have to design this actually around the radius that you're trying to bend around. This hinge type is fairly easy to manufacture. It's not ideal because you have so much precision in it, but it can be made very chunky, and depending on the end application, it looks really good and it can last a very long time because you have so much distributed motion. You don't have any single force on any single area, so it takes a long time for a hinge like this to completely fatigue and break away. But this is all in the traditional living hinges, and a living hinge is one where you have the material itself flex, and that's not a very good way of making a hinge. What if you could just do the hinge traditionally where it actually moves around an axle? Here 3D printing has a really fantastic advantage because it's able to make parts inside of other parts without actually having to assemble anything. So you have these hinges where you can have a flexible point moving around a central axle that was all printed as a single piece. These are not screws. Nothing was screwed together. This part was grown like this. Now there's a couple of different ways of doing this. You can print this part vertically just like this, which gives you really nice motion around the central axle to where it's nice and smooth and circular and can be pretty high precision, but it can be tough to kind of design, and you have to be really careful to chamfer those inner axes so that you don't have interface or layers falling onto each other. But that can be a little bit weaker because the layer lines are now horizontal. So if you have a lot of torsional force on this, that's not ideal. Just make something thick and make sure you're designing for the process and it's not that big of an issue. But if for some reason you're trying to make this very, very small, then you would want to print it horizontally because then the layer lines are moving through the point of rotation. And now you have basically a traditional solid part. And while you still have the same kind of rotation, it can be a lot rougher. Hear that? That's because inside of the axle, there's a little bit of settling that happens, so it becomes a little bit oval. So this is generally for like cheaper applications. So there you can get away with this. And if you have a large hinge door on this, you have so much leverage on it that there's no way it would ever stick or have an issue, but it just isn't as smooth as the vertically printed option. So there you have it. There are all kinds of hinges that can be made, and with 3D printing, you can actually make impossible hinges that are not possible any other way. So depending on what your application is, use the best hinge that works for you based on the profile that you have, based on what your requirements are, and based on what your cost is. Just make sure that you're designing for the process.
So springs are pretty useful. So in this video, we're going to go through and discuss how to design different types of springs and many of the common types of springs that can be designed and mass-produced with 3D printing. So we're going to go over several different types of springs, from spiral to torsional to extension type of springs. And 3D printed springs have to be very different from any other types of springs. The one spring that we will never make is a coil spring. Coil springs don't work for 3D printing because you are not able to have a continuous, cohesive kind of path in order to create a coil spring. You would end up having the layer line split if you printed it vertically, and if you print it sideways, well, you actually can do that, but it's not really a coil spring. It's not combined in the way that you would normally do it. If you want to create an extension spring, a standard type of coil spring function, what you do is that instead of doing a spiral, you just look at that spiral from the top and create that profile. And now you have a very simple flat pack extension spring. These types of extension springs are really useful if you want to have some sort of resistance on a switch or a button or whatever it happens to be, or if you need something that just gives really easily right there. All it is a simple curved path going back and forth, and you can change how that path works. Most of the time, the easiest way to do it is just kind of design a set of patterned slots and make sure you round out the edges. To make sure you round out the edges, sometimes people make these springs like perfectly square, but the problem with that is that you then have a stress concentration at those corners. Make sure it's round. Now, do these springs compare to regular circular extension springs? Well, quite frankly, they're not quite as good because regular circular extension springs are phenomenally efficient because they distribute the force perfectly continuously all the way around that coil. Whereas with these types of extension springs, the force is concentrated at the rotation points. So if this breaks, it's going to break right there just below the curve where this thing is bending. Now, as far as the actual design of these, the easiest way to do it is make these things thicker. If you want it to be stiffer, make them thinner down to 1 millimeter if you want them to be softer. And one other way of making it a little bit tougher is to go from a very flat design to a very thick design, where now you have a lot more material which is able to bend, so you can get a lot more resistance than what you would normally have. So those are the traditional kind of extension springs. But there's a lot of ways of rejiggering this because 3D printing lets you create weird and interesting geometries that generally don't come up very often. So what if you want just like a stabilizer ring? This is something where you would like mount something to a wall or to a brick, and then you would have the actual item mounted on the inside. It might be some sort of transfer or transmission, or just something that you want to vibrationally stabilize. These types of springs can stabilize in this direction because they're basically a set of extension springs around the outer side, or it can serve as like a trampoline where you can mount something up there and then this gives and gives slack in that way, kind of like a membrane. This is a very useful type of spring for push buttons and that kind of stuff. If you had a box and you wanted to have a push button on the inside, you can design this type of spring so that this becomes the big red power button for the box and then depresses whatever is underneath. So that's kind of the utility of these types of springs. Now we start getting into other types of very traditional types of springs. Leaf springs. Leaf springs are another sort of mounting, stabilizing sort of spring where you want something to stay in position for the most part with a little bit of compliance. These can both compress and also slide side to side. They can be very useful because with leaf springs, you're able to create items where you want kind of tight control. You can create effectively like parallel mechanisms with leaf springs so that you can keep the orientation of a part in the same place as you move and depress it around. So leaf springs are useful for creating kind of controlled mechanisms while still having all the vibration, dampening, deadening, and return that you want from traditional types of springs. However, these can be really finicky. You only have 1 or 2 bands of material to work with, so changing their strength is generally only through thickening something up. And now these can be really useful because a leaf spring is basically the material itself flexing by itself. So a leaf spring can be anything from a flat printed plate that's then bolted into place to these nicely little designed rings that again are printed in plane. This is the most important thing with 3D printed springs. All of the force has to be in plane along the layer lines to make sure that you don't have something snapping off. If you try to print this spring at an angle, you just ruined the spring. It has way less return. But leaf springs are terribly useful. And then last, but certainly not least, spiral springs. Very often you see these in clocks. These springs are generally energy storage devices. As compared to all the other ones, which are stabilizers, vibration deadening, that kind of stuff, coil springs are really about storing up energy because you have all these coils very densely packed. And again, you can make these springs thicker so that you can store up a lot more energy inside of these. So wind-up toys, mechanisms for lids, all those types of things can be done with coil springs. It's a very tight, compact way of getting twisting motion into a space. You can make the hole feed thicker in order to make it much stiffer on the outside if you're just wanting a spring for like opening a lid and then closing a lid. Or you can make it thinner, have many more coils, and then make it thicker in this direction in order to create much more energy storage. But those are the primary types of springs that you will see with 3D printing. One side benefit of almost all of them is that since they are printed flat, many of them can be printed within a print themselves. So if you have some plastic part that has been printed like this, you can continue printing the spring inside of the part and fully encase it in a way that you cannot with other processes. So you're effectively assembling a machine as it's being actually manufactured. So you can have springs embedded inside a system so that you now have a deadening, dampening feature inside of the part that otherwise would have had to be installed or built in 3 pieces or something like that. 3D printing lets you grow up an entire part with springs and mechanisms inside of it, which is pretty darn cool and something that has never been possible for with traditional manufacturing. So how do you actually design some hinges? Today we're going to go through that and probably show you some hinge designs that you've never seen before. So hinges are pretty darn useful, but they're actually quite challenging to do inside of 3D printing because you have to deal with orientation as well as the strength of the hinge. So we're going to start with kind of the least complex going up to the most complex types of hinges and how they can be useful and in what context they can be used. Well, one of the easiest ones is just a simple mechanical linkage. You have a loop and you have a solid rod going through the middle. Now, the trick with this is that it does have to be printed in this orientation. This orientation is super important because you need that center pin inside of there, that is the crossbar. You want that to be in the plane of the layers, because if we print it like this, it's no longer in the plane of the layers, so it could potentially break off if you just have a central hinge because it'll tear out through the layers. Now, there's ways of dealing with that, and we'll get to that here in another couple of hinges, but whenever doing this sort of hinge, you want to print it effectively horizontally, and you can create a really good, reliable hinge. But Gabe, what if I don't want to print it like that? What if I do have a box and I need to print it up on edge? Well, now you can use one of the more unique sort of hinges. This hinge is basically a cone-shaped hinge. You can see that even though it's level there, I can't actually pull it out of the hole that it's inside of. And the reason for that is that the inside of this actually splays out and is coned so that it's all print in place, but you still have freedom of motion and no side travel. It's still all retained, it's still all constrained, it's held together, but you get really good free flow motion in the vertical. Now, the issue with this is that this is a weaker hinge. Right now, all the layer lines are like this, so if I twist really hard right here, I can potentially break off this hinge. But again, if you make it large and chunky, you can compensate for that a little bit, and there's one more hinge type that is actually way better at getting this done. That hinge type is this one right here. This hinge is basically 2 cones on the top and on the bottom. And what this allows you to do is create a really robust contact point that doesn't have leverage. This can break off because there's a lot of leverage on that arm. All of the force from down here is applied up here, so you can break right at that corner up here at the top. But this one doesn't have a lever arm on it. The cones going into it are only about a couple millimeters or so you have a lot of motion and a lot of strength here, and you're never gonna break this off. Now, the challenge with this type of a hinge now is since it's not constrained the way this one is, this is a cone going up to the top and it's free, this one doesn't really have any overhangs that are an issue. This one has overhangs that are an issue and can cause fusing inside of the part. Even right here, you can kind of see the messiness because the top loop has to settle onto this bottom loop. And that causes an issue because now you have the material kind of falling down onto the other one so that one link of the hinge kind of acts as support for the other link of the hinge. This is not the end of the world, but it's not very robust. So there's a few things that you can do to kind of readjust around this. The way of doing that is basically taking this hinge and then just making the second half of it so that you have cone and then back up and then cone again. This way you are able to create something that doesn't really have the overhangs because everything blends into itself. And even though you have that center spiral, it can't break off because you have that baseline chamfered and really strong and reliable. So it's kind of a hybrid of this just standard one with just cones on top and then a center area and then a bottom. You actually connect to those 2 top cones, so it's a lot easier. The other thing that you can do in order to refine this even more is to put 1 cone on the bottom and then 1 cone on the top of the other link. This way you have nothing falling down onto the print at all. It's all just perfect vertical roofs that are a lot more reliable to print with. And the one other option is to again change orientation. This hinge right here has the top link falling down on the bottom. This hinge is this hinge but printed on its side. This allows you to now put those cones in plane. And since those cones are inside of there and they're cones, they have no overhang again. So you end up with a really tight and reliable hinge. This linkage is really good for high tolerance parts and pieces. But this is printed on its side, whereas this one is printed in this orientation, this one is printed in this orientation, as if this was on its side. This is really strong, really robust hinge, generally has really good tolerances, but again, it has to be printed like this, which can be limiting because sometimes you have a hinge going up the spine of some sort of a part. But if you ever have to print something vertical like this, you need to be really wary of the overhangs because you cannot rely on slicer settings of it works on my machine, why doesn't it work on this machine? It's just not robust because different materials, different dyes, everything can change how that interaction occurs. So you want to make a robust print that's really reliable. So hopefully that gave you some insight around how to design different sorts of hinges and the things that you can do with them. The reason this is so important is because there's a lot of applications where you don't want to be reliant on your particular 3D printer. If you wanted to upload something like this to our teleport plugin, where you want to sell a bunch of them but you don't want to have to run a print farm, you just upload the model and then when a customer orders it, we print and ship it to them for you. If you want to do that, you need a robust model because our machines are not your machines. You want the model itself to be reliable and not have to rely on the slicer settings or the material or anything else. Just design well and all the slicer settings become irrelevant. This model done well, like this, can be printed at 0.1, 0.2, 0.3 resolution with any sort of infill and with any sort of material, and it will still work just fine. That is the power of really, really good design. So hopefully that helps you out. Have a great day, everybody.
I wave my hand, but it won't mean hello. No, bye. We ride, they wine, whip it out on him, hoping he falls like echo. Been pulling them strings, no cello. Whip it out when we hop out and whips. Bro got his quick thing, how he whips it. That's that white cream like whip. Whipped it out, licked it down, now she's whipped. See it up in this whip, still spinning. Even if it's hot, cause the whip being's legit. Still take that risk, even though we on dingers. Whip it out when we hop out and whips. Bro got his quick thing, how he whips it. That's that white cream like whip. Whipped it out, licked it down, now she's whipped. See it up in this whip, still spinning. Even if it's hot, cause the whip being's legit. Still take that risk, even though we on dingers.
Still here, friend. Whoa, excuse me. It's gonna cost a little, but I can hook us up. Hey, Mom. Mom, This country is just giving away its money to other countries. You got to start buying American.
It's moving day. That's right, Mint Mobile is coming home to your home. I mean, if you'll have us. It's internet for your home from Mint. Minternet. Fast 5G home internet powered by T-Mobile for $30 a month. No more triple-digit monthly bills or waiting for the cable guy to show up and silently judge your home decor. You've crossed the 2-foot perimeter, so back off or I will stab you both in the d***. The highly visible d***.
Germs. It's kill or be killed in the
So
Great
sometimes you
Warfare
want
in your
multiple
home,
3D
of
printed
all
parts to
places
stick
in
together,
Europe.
and you don't want to use screws, you don't want to do magnets, you just want something to snap. Just snap, snap, snap. So in this video, we're going to go through 5 different ways about how to make items that will actually allow you to connect them together really reliably. And we'll show you how to design them so that they work on any machine, anytime, anywhere, and are never dependent on settings. Comment down below if there's any other that you would like us to see at the end of the video.
So there are a lot of different ways of sticking two parts together. You can screw them together, you can glue them together, or you can design in fasteners themselves into the parts so that they snap together. But in this video, we're going to go through some basic connectors to join larger 3D printed parts together if you're trying to make a larger one out of a few smaller ones. So the first and very simplest way of doing this is with a peg and hole, but most people would generally go to a round peg and a round hole. You don't want to do this. A round hole will sag and be dimensionally off a little bit to where you don't have a good grip, and a round peg can't really be printed in a horizontal orientation to where it can be strong. You don't want the pegs to be in plane with the layers because they'll just snap off. So instead, to avoid all of these problems, take a square peg and make it diagonal. Turn it sideways, and now you have a diamond hole and a diamond peg. This diamond hole makes sure that there's no overhang areas, so it's very dimensionally precise, and you're able to print the square peg horizontally on the print bed so that it's as strong as it would ever need to be to hold the two parts together. But it's only held together by the actual friction of the parts themselves. Now, the square peg is fine, but what if you want something that's kind of low profile? Maybe you have a really thin part, or you're trying to peg around the outer edge. You don't want to do small little diamond holes, and you want something a little bit more universal and robust. Well, in this case, go ahead and do like a slab and slot. This is really easy to do, and you're able to create something really reliable. Just make sure that you are tapering the ends of whatever the peg is that you're putting inside of there, the slab that we're going to shove inside of there. Taper it off, round it off so that it slides in and then gets tighter as it goes in, because it can connect with the walls of the part even better. And this is how you can create a really low profile connecting option. Now, these are both fine, but pegs have an issue. Pegs can have a really big gap in between, because as you're pressing a part together, if you have a really broad face, it can flex because it's plastic. And if it flexes and you press the two things together, and on the outer edges they come together, but then the flex pops them back loose a little bit. So you end up with a bigger gap that you can't really overcome without making the part just stiffer so it can't flex as much, but that increases cost. You don't want to do that. So you need something that is able to press together easily, but then hold and retain in a precise position, and even stronger than what you would normally have. There's a couple of options for this one. The first one we're going to look at is basically just a little S bracket. You design in a hole into the part to where you can slide in the side bracket and then slide it into a slot to where it will snap into a small slot inside of the part. This is a really good way of doing it. It is symmetric, so you can replicate that hole all throughout your part, and you can change the size of the connector piece in order to increase the amount of compression on there. This is a really good way of combining two pieces, and it's a very simple piece. Of course, make sure you round it all out so that it has nice, easy corners and is easy to print, but you can make this as thick as you want to make it stronger, but this is a very simple way to have a very precise joining position. Another way of doing this that's a little bit more complex and a little bit less reliable is to use basically snap fits, where you design a double-sided C-clamp to where you can press it into a slot and then it slots into a couple of holes inside of the part. This is a really good way of doing it. It's very easy, it's very intuitive, it doesn't require a lot of training like the S one kind of does. But it can be less robust because it has to be able to flex. The S is a piece of hardware being shoved into a piece of hardware. This is a mechanism, and as a mechanism, it might need to be designed just right so that it can squeeze and have enough pressure, and the latches have to contact just right. It can be tougher because you're pressing things together again rather than squeezing them together to where you can kind of do an over-center clamp thing. So of all of these options, the peg is the easiest. If you're going to use some glue, just go ahead and use a peg. Use the slab if you are going around a thin profile of a small part. You can use the S if you want it as strong as possible and still very concise and tight. And you can use the snap fit if you want something really fast and easy that doesn't require any pressure and still has a pretty tight and reliable fit. You know, sometimes you want multiple parts to stick together, but you want to do it in a way to make sure they stay together consistently, reliably, and continuously. So in this video, we're going to go through joining features, how a lot of people design them, and some better ways of actually getting them made to have your parts stick together really well. So the first and most common type of joining feature is really just a tongue and a slot. And this is a decent way of doing it because it's easy. You make a square on one side and a square on another side, and then you have them slide together or press together. And this isn't a bad deal, but it's kind of not very useful because they don't hold together very well. But if you are designing these, make sure that you chamfer the insert just a little bit. That way it's able to wedge into the main slot. And then the 3D printed layer lines can actually cause them to lock together pretty reliably. But again, you don't have any sort of pull or forcing to make sure that there's no gap in between the two pieces. Also, it's just kind of cumbersome because there's a lot of tolerance issues within it. So this isn't the greatest type of locking feature, though it's the one that a lot of people go to. But let's move into one that's a little bit more robust. Another option that a lot of people use are T-slots, and T-slots are actually pretty decent because they actually have some lateral support, so I can't pull these apart. and they're actually not too bad to design, and you can actually use the same kind of chamfering on the top of the tongue itself so that it angles up and locks into there. And this is fine, but the problem is that you now have several different tolerances to have to deal with. You also have a pretty complex first layer where this can warp and curl up when it's going down on the first layer if you're using a high warp material or want something that's robust in manufacturing. So even though it is functionally okay, it's not great. And again, you have the tolerance issues of having to keep that seam pulled together. And based on material shrinkage and other types of issues, this won't always work very well. So having something that is tight and flush, just like this, isn't always a very viable option. But there's an upgrade to the T-slot, and that is this. You can actually take the T-slot and curve it just a bit so that now you have taken the two outer flanges of the T-slot, and instead of them being straight to where they press into a hole with a friction fit, they are instead acting like springs. So that now you have a part that is able to go into the slot and lock in so that now there is no jiggle, no tolerance issues at all, and you're able to have kind of flexible tolerances that you can deal with material shrinkage and other types.
Right over there right now.
But I know you can't.
What you want to do is save hundreds when Liberty Mutual customizes your car insurance.
That's great, but can you ask your friend to stop digging into the green?
I can ask, but he's not going to. Only pay for what you need.
Welcome back. Today we're looking at old scary YouTube videos. Ooh. So listen, I'm an old guy as far as the internet goes, all right? When YouTube came out, I was in my teens, okay? I remember YouTube beginning. I know YouTube's for all ages. There's people much older than I am, people much younger than I am on here. But when I tell you I was there day one, I mean it. And the first couple years of YouTube were special. You know, it was like this new era of people just uploading whatever. You had funny videos, you had sketches, you had music videos. It was just like the Wild West. But sometimes you'd catch a video or a clip where you had no context for it. And that's what made this so special. You'd find a clip of something weird happening. And this is pre-AI making any sort of creepy thing possible. This is before everyone had, you know, editing abilities or like editing software got as good as it is now for the average person. When you saw a clip of something creepy happening that looked convincing, it was like, is this real? Plus me being like a kid, you know, like me and my friends being like, is this real? I think this era of YouTube horror and just internet horror is like why my channel is what it is today. Like it's very horror centric because internet horror is like fun. It's like our modern equivalent of finding a VHS tape in the attic that has some creepy footage on it, you know? You don't get the context, you just find this video in a sea of other videos that are normal and you're just like, what's up with this clip though? Where did this come from? Did someone make this? Is this authentic? And you never get the answer. That's the scariest part. So we're looking at videos from like 15-ish years ago on YouTube. Some older than that, some a little newer than that, but roughly 15 years ago is kind of the era lots of these are from, which is fun. Are you excited for this? This is gonna be fun, okay? I got some absolute bangers in here that I remember so much from when I was younger, and also some ones that I found a little later on, and a couple that I found today that I just never quite caught back then. So a nice mix. Let's jump into it, all right? You can just pretend these are all new if you want. If you're scared of like this weird old guy, old YouTube horror, it's just gonna be like TikTok horror, I promise. It's just that these are like a little more authentic than like just AI generated slop. Not that I ever show that on my channel, but that is unfortunately what you have to dig through to find horror these days. So here we go. Starting off with a simple one. This one is just called Flying Girl in Russian Wood. And yes, the frame rate is like 10 on this one. But just this one, don't worry.
А теперь ко мне.
It's a pretty clear camera for 16 years ago, though.
Тарзан. Тарзан, я сказал, ко мне. Тарзан, ко мне. Что это? Тихо, тихо, Тарзан. Тарзан, тихо, тихо, Тарзан. Боже мой, что это было?
What did you think of that? See? 16 years ago. All right, this video was posted March 2nd of 2009. The fact that the footage is strangely clear for being this old makes it feel even more authentic. Like you could fake this if you had just like a super low res camera. There could be like an obvious rope in the shot or, you know, like a ladder. But if it's such a low res camera, you couldn't really tell. So you could just do any number of methods to make this look like this. But look at this, you know? And again, what makes videos like this so much weirder is it's the only video on this channel. Still, this video got almost 3 million views, and that's it, just the one video. Why? It's the context or the lack thereof around these videos that makes them so impactful. There's nothing inherently like that scary about a girl flying, but it's a very bizarre video. You know, it does feel like a video of a guy with his dog out in the woods and then he just sees that, you know, he's speaking Russian. It's such a weird video with no context, and we're not gonna get the context. Even if it's out there on the internet, I'm not gonna look it up. I don't want the context. I like this video as it is. Then we got videos like this from a channel called Alan Tutorial, who did a lot of videos like this one, where they're just like bizarre. What'd you think of that one, huh? Now this channel has a lot more videos on it over the course of a couple years. It was framed like a tutorial channel, but everything was just really wrong in all the tutorials. And then of course the video I just showed you, it's not a tutorial at all. It's just called TT, which, you know, you could pronounce as tutorial, I guess. Yeah, so pretty bizarre stuff, but these videos got multiple million views, and then one day they just never posted again. And then we're just left to wonder, you know? Isn't that crazy? A lot of stuff like this, although some of the ones we're gonna look at coming up are like very purposeful horror series that were like made to be entertaining, you know? Stuff like this is just bizarre, out of context. It just makes you feel kind of weird, you know? You're like 99% sure this person was like playing a character and this was made to be disturbing, but you never get the confirmation that's the case. So like, I'm sorry, Alan Tutorial, if you were actually having a mental breakdown and you needed some help and we were all just like, whoa, this guy's tutorial videos are so wacky. But I don't know, man. Okay, this next one, this is the golden goose. All right, this is the top of the top. This is not a found footage in the sense that it's like a random no context clip. This is a series purposely made to be spooky, but through the lens of it being found footage, but it was made on purpose. You know, this isn't like a weird clip. This is a series made by like a group of guys that wanted this to be a web series, you know? It's called Marble Hornets, and this went on for a couple years. They would put an entry into the saga every couple of weeks or a couple months or whatever, and it would be like just another found footage, give you a little more context of what's going on, something spooky would happen. But let me just show you entry one. Entry 1. After viewing a couple of tapes and finding nothing unusual, it came across a clip that doesn't fit in with the others. From what I can tell, the following footage takes place inside Alex's house, not the set for Marble Hornets. The audio has been removed, either the microphone was disabled at the time or it was taken out afterwards. Big shadow. This was the only thing that was out of the ordinary on this particular tape. After seeing this clip, I'll keep an eye out for occurrences similar to this one in the future. This is gonna sound crazy, what I'm about to say. All right, for those of us that have been on the internet for a while, there was once a time that Slender Man, as a scary creature, was not cringe and overused. It was actually scary at one point when it was new. When that first Slender Man game came out and Marble Hornets was happening, Slender Man was like a scary entity. This mysterious, well-dressed, blank-faced guy that would just be out in the woods with super long arms. Scary. Now, 15 years have gone by and it's been overused and we've seen it and we all got bored of it 10 years ago or so. But at one point, this stuff hit. It really did. So Marble Hornets was the name of a student film that was being made like in this universe. So the footage of the entries was like the group of guys making this student film, which is why they were filming everything, documenting the process of making a student film. But along the way, they kept catching wind of weird things. They kept ending up in weird locations when they were scouting for their movie or whatever. And then they kept seeing strange things. This happened in 2009 and they put out the next entry every couple weeks or couple months or whatever. And I was watching this when it happened. This was my like week-to-week TV that I wanted to watch. I could not wait for the next entry every time. And it was super slow burn. This is entry 1, 2009. Entry 40, 2011. Over 2 years later, this is May, was like the first time after 2 years of watching this that we got a really true look at Slender Man in this. And this was like, talk about slow burn buildup. Check this out. Pretty crazy. Let me tell you, when I saw this at age, whatever I would have been, 17 or something, I was spooked. I'd spent 2 years building up to this moment and seeing Slender Man for like, you see him a little bit here and there, but this is the first time he gets you. Anyway, fantastic series. I could make a whole video talking about just this series. I'm not going to. That's not my style, but Marble Hornets, okay? Fantastic time. Early YouTube found footage series on old camcorders with good sound design, and they took the time to kind of lull you into a false sense of security, then something weird would happen. It was perfect, dude. It was fantastic. I forget, but I think it went on a little too long, and then there were some pretty big gaps between episodes towards the end, but it had a solid 2 or so year run, which is great. Okay, similar vein, something that was well crafted and purposely spooky. I have to mention this. I won't linger on it because it's like a full production, but Don't Hug Me, I'm Scared is this one. Has to be mentioned. This is 14 years ago. You can tell this has a very polished look to it off the bat. This is a whole different animal than like Marble Hornets or these other clips in the woods. So here's this. It was this high budget, kind of Sesame Street style of kind of musical where they had songs and stuff. And there was 5 parts, I believe, and every part kind of started off pretty normal, had like kind of a catchy, kidsy song, and then things would just kind of get weird at some point. I don't think I can show much of it because of just like copyright. This is like a full production. But if you haven't heard of this and you like weird, creepy horror, definitely check this out. This is something that when this came out, it was kind of mind blowing because it was like still YouTube and it was still horror, but it was so well made with like full production that it made it like that much creepier because it was like, what is the context of this? You know? Who spent tens of thousands of dollars probably and had multiple set designers and teams and costumes and, all this stuff to make this creepy series. I mean, this has 82 million views. This is like the beginning of YouTube being like just like any other streaming service where like there was just top tier quality stuff on here, but absolutely worth mentioning. It's a main staple of YouTube horror from back in the day. And on a similar note, this one, I always don't like watching this one, but here we go. We can't skip this one. This one's called Dining Room or There Is Nothing. 19 years ago, 2006, dude. Chances are you've seen this, all right? But if you haven't, buckle up.
Listen, it's called Connect Team, and it's insane. I don't do schedules or timesheets manually anymore.
And it works?
Oh, like you wouldn't believe it. My team puts in their availability, I click auto schedule, and boom, there it goes. No more Excel, no more phone calls, no more group chats. Oh. Perfect schedule, like that.
Damn, so all you gotta do is post it.
Yeah, my team loves that it's just one app, so they see their shifts, they can approve it, and I know it's covered.
But wait, what if there's like a last minute change? I mean, that's the afternoon gone, right?
So in that case, I just blast a shift for my team to claim, everyone sees it, and I just assign the first one to pick it up. It literally takes 2 minutes. I'm telling you, it's all in the app. So they clock in, I can see who's working, who's late in real time, and their hours go straight to their timesheets, so I don't have to do anything.
Wow.
Yeah. I'm embarrassed to say, I used to spend 3 days prepping timesheets for payroll. Now it takes, what, half a day, tops?
Nah, I gotta check this out.
You should.
You're back.
There is nothing.
Yeah, man, that's the video. What'd you think of that, huh? This person did go on to make like a bunch of other horror stuff. Like they ended up being like an actual, I don't think they have much on their channel, but they like, you know, they got a website and stuff. But this is like one of the first things. At the time, there was no context for this. But obviously, there was some budget. You know, there's fire in the background. That's cool. It looks pretty real. Could have been like a green screen thing. I don't know. There's a whole creepy vibe to it. Good camera work. But to explain it to you, because somehow I always have to explain it even though it's really obvious. But the entire video is only 30 seconds long, but then they play it backwards, starting about here. You can see the fire kind of switch right there. It starts going backwards. So this bit at the beginning of them speaking is them literally talking backwards. Like this is them talking backwards, not reversed. This is them saying what they wanted to say, but backwards. And it's creepy, all right? They say that, then they die, dead for a while, then they come back. And this is reversed. So now what they said at the beginning is now reversed, and we learn that they said... There's nothing. So they died, they went to the afterlife, or I guess in this case, a lack thereof. So the whole thing is so scary, you know? It's just like, what's up with this person? They don't seem okay. Then they die and they come back? Also, what's the fire doing, you know? That's not a good sign. There's probably more to it than that, maybe. There's probably more symbology than that, but that's just what I feel about it, and it always kind of creeps me out. It's great. The piano in the background is so creepy. I hate it, dude. It's well crafted. I hate it so much. This one, we're not gonna linger on this one either, but dude, if you were around in this time on the internet, you know this. You know this very well. Don't worry, I'm not gonna let it jump scare you. But this was a web game where you had to move the little square with your mouse without touching the walls, because you had to start over if you touched the walls. And so you would have to go and you have to be really careful. And so the whole point of the game is that once you got to this part of the game, you had to really lean forward in your seat to really pixel perfect move the square up this thing and up and around and over. And then when you were in the middle of doing that, it would jump scare you with this image and a scream. Ready to hear the scream? Here comes the scream. And boy, oh boy, did I get with this when I was like 13. I remember my friends being like, play this little web game. And I was so trusting. That was the last time I was a trusting guy. I was like, oh, they want me to play this game and they're filming me play it. I didn't think anything of that. They were sitting there giggling with their little cameras like this, laughing at me playing this little maze game. And I was like, sure, I guess this is a cool game. You were excited to see me play. I got jump scared to smithereens, okay? My ability to handle horror of any kind at age 12 or whatever I was, 0. I don't think I peed my pants, but I would have. Maybe I already went to the bathroom, but this is the situation I would have peed my pants. I did not like that. And I don't think I've trusted anyone ever since then. I'm joking, but this is like top tier. Like, you should know this if you were on the internet. And maybe if you don't know this, congratulations, your friends liked you, I guess. They didn't want to terrify you for their own amusement. But yeah, classic little web game with a jump scare. What a great time. There was also lots of videos this era where it would play a video that was kind of random and then it would just jump scare you somewhere towards the end of the video. You just couldn't trust any videos back then. If someone sent you a video, it was like, is this a video you want me to see? Because it seems kind of random. Then the jump scare would happen and you'd be like, oh, that's why you sent me this video. I get it. To terrify me. Cool. Okay, here's another one. I don't think we're gonna watch this whole thing, but another video that was just very strange to watch back in the day without any context.
Monday.com, the opposite of any work platform we tried in the past. We tried other work management platforms, not naming names. They all suck. Monday, total opposite. It didn't just work, it spread. And people became Monday evangelists. And you know why? Because people actually liked using it. Now, it's not a chore. It's intuitive. You don't have to force anyone. They're on board. You can really see that Monday care about their user. The user is king. You can create workflows yourselves, no IT, no admins. And that's why we love it. There's no roadblocks. Everything can just be done instantly. We have people creating workflows and showing them off around the company. They take pride in it. I know it sounds like a commercial, but honestly, I never expected it to have this much influence. If you ask me, what's one piece of software you can't live without? Monday, hands down. Everything else, dispensable. If anyone tries to take it away from us, there would be riots. So yeah. If you're still on the fence, just try it.
Off to a good start, right? This video will be a fun experience. Yikes, I forgot about the little jump scare there. It's a cooking video. I cook the tomatoes. Let's cooking. Please prepare the tomato. I don't know if this music is copyrighted, so I kind of got to flip around a little bit, but the video, they accidentally cut their neck while cutting the tomato. Things get a little freaky. And then this happens. And that's pretty much the video. Is that fun? Did you enjoy that? What's funny about this channel these days is that they have a Minecraft Let's Play. Just like a normal Minecraft Let's Play. So we get some context for once, and it's honestly pretty good. It's just someone made this when they were younger, I guess, somehow. It's impressive. I don't know how old they were then and how old they are now playing Minecraft, but 15 years ago they made this, and nowadays they're just playing Minecraft. You know, everything has a happy ending. Okay, here's another classic you probably have seen. Sewer creature spotted. Just glowing eyes around the corner. This looks like catacombs almost. Such a scary tunnel. Yeah, dude, look at that. Man. Oh, dude, I didn't realize that we saw so much of it. Dude, it moves so fast. And that's the whole video. What's crazy about this one is that their whole channel, even back then and up until now, the channel's called United Utilities, and it really is just like a utilities channel. Even back then and still up till now, they're talking about water meters, pipes, you know, just sewage and stuff. All the way. For 10 years, they've been posting normal water type videos ever since. Look at this. This is like legit professional, well-shot water like conservation type videos on the same channel. But if you go to the beginning, you have this sewer creature video. Like, huh? Did they make this to be scary on purpose? Surely, right? I don't believe that this really happened. But why is it on this channel? Why did they make this? I don't know. You know what I mean? Like the context. I don't know. It's so much scarier when the context makes you more bewildered. I'm like, oh, you see this video and you're like, oh, surely, you know, it's just some guys making a scary video or something, you know? This is a guy in a costume. Then I'm like, wait, this is actually just like a sewage water conservation channel. United Utilities. They've been at it for 15 years. Why is this on their channel? The description kind of gives you what they were going for. Do you know what gruesome monsters are lurking in the sewers? Let's banish the fatberg and spread the word to only flush the 3 P's. Pee, paper, and poo. So it's kind of like a don't flush things you're not supposed to kind of PSA, which is like, yeah, that makes sense. But what the hell? How did you make this? Why did you make this? And why does it look kind of good? And it's so out of character to do this on this otherwise very professional channel. Anyway, I love it. I think it's fantastic. The context of this one is like my favorite part about it. The fact that this is just like a utilities page and this video is from their page. So funny. Okay, here's a couple of just like iconic creepy videos. Haunted doll moves head on camera. One more time. It does turn its head. It wouldn't be super hard to make this happen for a fake video, you know? There could be someone standing behind her. They did put the mirror right here, but the hand could be like in the hair. But you know, classic. Just a no context, random, scary video with a very realistic scream, if I do say so myself. Like, that's a fearful scream. It actually like gives me chills how good of a scream that is. Like, it's so scary. Like, she's just shocked to look over her doll and see it looking at her when it wasn't a second ago. Just a good video, you know? It's just fantastic. I don't think this is the original channel for this clip. This one's just 7 years ago, but this is them saying that they remember this video and re-uploaded it. This video is much older. As you can tell by the quality of it, this is another like 15, 16-year-old video. Scary. It was a wild time back then, man. Okay, this is not a YouTube video necessarily, but I have to include it because I saw it on YouTube back in the day. It's a movie called The Adventures of Mark Twain, and this is a scene about a character called the Mysterious Stranger. And let me just play the first 30 seconds for you. This is a proper movie, but I saw it on YouTube and it was popular on YouTube.
Fame is a vapor. The only earthly certainty is oblivion.
Welcome to the Mysterious Stranger.
Hello. Who are you? An angel.
What's your name?
Satan. Uh-oh. What's the matter?
Nothing. Only it's sure a sorry name for an angel.
Please, come in.
Come on.
Like, what the hell? You know what I mean? This is a kid's movie. Also, the randomest thing. I mean, it's supposed to be Mark Twain and the characters from his writings kind of like spliced into like a supercut movie where they're in like this spacecraft time travel machine thing. And so they kind of like teleport through instances of things from his stories. I guess that's the best way I could explain it. Like, this is supposed to be Huckleberry Finn. Isn't that very strange that this exists like this? And they created like the scariest character of all time. And that's not even the worst part of it. Like, it's pretty weird, man.
Fools. What fascinations there are on this planet.
You, just you, building your app on base 44. Describe it. And it's real. One thought leads to more thoughts. Layer by layer, taking shape. When you need your tools, bring them in. They just click. Okay, kick it up a notch. Create something smarter, something powerful. Style counts, so give it your touch. Big or small. Next idea hits at 2 a.m. Of course it does. Keep building. Ask yourself, wait, I built this? Damn right. Base 44. Build it your way.
This is a little bit of a on the edge. Like, it's not like a YouTube video, like I said, so we'll move on. But this is just crazy, man. This is some crazy stuff. I gotta sit down and watch this whole movie sometime. I've only ever seen this like 5-minute video, and it's some bizarro world existential horror for kids in claymation. Isn't that fun? Okay, this next one, I will put it in the same vein as Marble Hornets, but smaller, shorter, and probably less scary. But spoilers, still Slender Man. Same era, 15-ish years ago. It was a all-in character kind of fitness page, sort of like the science of fitness type thing.
What's going on, Internet? I'm Vinny Everyman, and this is Everyman Hybrid. We're here to show you that you don't need those ridiculously expensive gym passes and harsh regimens to maintain a healthier, happier lifestyle.
So they have 5 videos that are like 99% of each video is just like a straight-faced fitness advice, things you should do, things that they've been up to, things they've learned, things they want to share with you. Very like professional content. But then something weird just happens a little bit in each video, like this one.
It's very exciting. Sorry, it's a thing here. I might have to go soon because I can see some blue lights. But yeah, give me a shout out if you can.
Just like 1 second of Scary Woods at the end.
How's it going, Interweb?
Then same thing. They're out for a jog, they're talking about fitness or whatever. Nothing really happens in this episode, but in episode 4, do you see it? There's a pole, there's his friend, and then right behind it, a familiar shape. A man that is quite slender. You don't believe me? Watch this next scene.
Now, when you want
Dude, he's standing right behind you. He's not even hiding, he's just right behind you. Survival skills, absolutely 0, dude. But yeah, this is one, I don't think it ranks as scary, but I like how much they leaned into their characters of just like being like a fitness and outdoor activity, cardio, you know, advice, whatever page, with just like maybe 2 seconds per video where something's kind of off. And it's not even like in your face. It's just, it's subtle a lot of the times. I don't know if these did that well at the time, but you can clearly tell what they were going for. They might have seen Marble Hornets and had a similar idea, or maybe they just had kind of a similar idea just by happenstance, but worth mentioning. Definitely a fun little nostalgic page. Here's one where you can just see Slender Man in the window back here, I'm pretty sure.
Now again, it's very
but you're right there.
slowly. You bring them down to the starting position every time.
Pretty creepy. It's really funny to think of Slender Man being like the monster. It's the reason like it was so scary when it was new that it got so overdone, which is why we all that are familiar with it view it as like very not scary and kind of cringe. It's like being genuinely terrified of like Five Nights at Freddy's. You know, it's like we're all older now. That thing was scary when it was new and we were little kids, but like it's just so overdone and everywhere and cheesy and we're all grown up that it's just like, it's silly to think that was ever scary. Same thing. Slender Man, it's a little silly now, but man, early days Slender Man was spooky, dude. I had one of the Slender Man games on my computer. I played it a lot, as in I started playing it a lot, never finished it, never even got that far. I would always get so scared I would close the game after like a couple minutes. It was so scary. But also I was like 14 probably, so we'll give me a little slack, but it was scary, man. I think it actually was. Okay, another classic for you. It doesn't really count as a YouTube video, even though that's just where we all saw it. This is a commercial. I'm gonna stop the video right here, okay? Because in a couple seconds, you get jump scared, okay? I'm not gonna do that to you. You don't need to go through that. This is a safe place. I'll play it with you now knowing that that happens. All right, we'll turn the volume down a little bit because it's very loud. It was an ad for coffee, you see, and it says, the tagline is, "You've never been so awake before." You know, like they like startled you awake, and that's what this coffee's gonna do. It's gonna scare you so much that you're wide awake and alert. So pretty funny, but this video has 3 million views, came out in 2006, but it was just an upload of a commercial in Germany, so maybe the commercial's even older than that, who knows? But yeah, that was one that got sent around a lot, because it was like, check out this funny commercial, and then it would just jump scare you. That's how That's how, let me take this off for a second, all right? I'm gonna yap for a second. That's how prevalent getting jump scared in a random video was. I cannot stress this enough. You guys are familiar with Rickrolling, right? Before Rickrolling, or maybe around the same time as Rickrolling was new, same thing. You'd get sent a video, normal video, but then there would be a jump scare just built into it somewhere. And that was like a weird paranoia that we all lived with because you just never knew when you were gonna get jump scared because it was such a big common occurrence that people would make these jump scare videos that a German coffee company made one. You know how brands are always like picking up on trends these days? It was much less common back then. So for a trend to be big enough to be in a German coffee commercial, that's how much of a thing getting randomly jump scared was. I feel like I've suppressed that because I forgot about that whole thing, but now that we're seeing it, I'm like, oh my gosh, yeah. The amount of times I would get jump scared for no reason, just on like a random Tuesday at 2 p.m., just browsing like regular safe content. Crazy. Okay, we got a couple more and then we'll call it a day, yeah? Okay, I won't linger on this one too long because this is like a full short film. Like it's like a mini stop motion movie that probably took a zillion hours to make. So I'm not gonna like chop it up and give you your little TV dinner of it. I'm just gonna kind of recommend it to you. But I will show you just a little clip to kind of give you an idea.
YouTube 2, G3. Titan B4. B5, 2, M2. Ben 1, 2, and 4. X1 to S2. V3 to V3. M3 to Q3. Warning, you are 15 seconds behind. If you can't not complete the order in 15 seconds, you will be officially cited.
We'll stop there, but let me tell you, it gets a lot wackier than that. But yeah, this is called Operator. It's by Sam Barnett. Obviously, the big content we look at today will be linked. I don't think I'm gonna be linking like ones like this that are re-uploaded of just like singular clips, but everything we've seen like Marble Hornets, Allen Tutorial, and things that were like content made, those will be linked. Definitely recommend this one. There's 3 parts of it. It's like maybe half an hour total. It's a good ride. It's a little, you know, dark, I would say, but I recommend it. Anything that has this much work put into it that's on YouTube, I gotta like use the small voice that I have on my corner of the website to like shine a light on things that just didn't get, I think, as much attention as they should have. Like 1.5 million views is pretty good, but like part 2 is only got 600K. You know, this is like a full stop motion horror film, like sci-fi horror film on YouTube. Go watch this, man. I'm telling you. Honorable mention. We've seen this before, probably even more than once. The Little Baby's ice cream commercial.
There's good reason for my glistening skin. And how I shine. And how my pores are so clean and clear.
It's so creepy, dude. We're not gonna watch the whole thing. It's just that, as you'd imagine.
High-five each other with great enthusiasm. This is a special time.
It's a real commercial. And honestly, this is how you get people to hear about your ice cream, I guess. Make the scariest commercial of all time. And then people like me are still watching it 13 years later, you know? What an ad for ice cream, huh?
When you eat Little Babies.
So disturbing, you know? I don't like it. It makes me very uncomfortable. Okay, there's no way I can talk about old YouTube horror and not talk about salad fingers. This had a chokehold on my older brother and everyone in that age bracket, like my older brother's age down to mine. It was like everyone was quoting it, doing this scary, creepy salad fingers voice. It was very quotable too. But yeah, people, I mean, if you saw this back in the day, you know what I'm talking about. Like, this was influential. This is salad fingers.
I like rusty spoons. I like to touch them. I must find the perfect spoon.
Yeah, I mean, you know, we could sit here and watch this. We really could, but I don't know if I want to watch this. It gets pretty disturbing.
Might I ask where you keep the spoons? I see. Then I must leave.
The voice of Salad Fingers is iconic for a reason, I would say. It's very unique and horrifying. It's so, like, gentle and, I don't know, it's like, you know, it's just like, ugh. It's just, ugh. It's very grating, you know? And it's a creepy character. It gets gradually more and more morbid as you go down. There's quite a few of these. But this came out in 2008. This has been around for 17 years. Almost 18 years. Crazy. All right. And this also did really well. Like, you've probably heard of this before. Part 2 has 25 million views. I don't know how many views the first part has because it looks like it got re-uploaded. Part 1 is only from like a couple months ago. So it got re-uploaded at some point. So who knows? But it's kind of fire, but it's also not my kind of thing. Episode 1 is iconic. I like it because it's just nostalgic in a horrible kind of way, but the rest of it, I'm not interested. I don't want to see where it all goes, you know? Okay, we got 2 more here before we wrap up. Here's just a random out of context clip on a random channel with no other things.